Well, hi. So here we are in our next episode of the restoration that we're going to be doing of this All-American 5 radio, Packard-Bell 501. And our progress so far is just basically taking the guts out of the case, kind of doing a visual inspection, seeing what's going on. We remove the tubes already, marking them, the ones that we were unsure of. We just kind of pointed out a couple of things. And one of the things that I have mentioned several times, and I continue to emphasize, is the fact that working on one of these old radios is actually a little bit dangerous. As I've repeatedly said, I'm not plugging this in until we get some basic work done. There's a couple of reasons for doing that. Number one, there's a danger of damaging some of the existing components. And number two is the fact that these radios were constructed, they took some shortcuts. So to avoid using a transformer, which is a particular device, you've probably seen them, you kind of know maybe what they're about. Transformers can be expensive and heavy, and so to cut down on the use of a transformer to provide power, they instead opted to, the manufacturers of these All-American 5s, instead opted to do something a little bit risky. They took the power off of the cord and they would make that power actually show up on the metal here. Now, in most American 5s, this is the case. In this case, in this particular model, I'm not sure that that's the case yet because there's no obvious connection, but I'm going to be checking that. The point is that that's one of the reasons why the All-American 5 manufacturers would make large cases that would try and cover up all the metal, including the back here. As you can see, this cardboard here is covering up most of the metal, so that really only the sliver would show, reducing the risk of shock. So what we're going to do is I'm going to talk about electricity, because it turns out that electricity coming out of your wall isn't quite what you think it is. So I'd like to talk about that a little bit and show you what it is that we're worried about here. So let's set up the lab bench here and I'll kind of show you what I'm talking about. Okay, well, let's begin with some basics. Here's a typical modern plug, 2 prongs, here and here. And as you've probably noticed, especially for those who are older, when that wasn't the case, one of these prongs is wider, this one, is wider than this one. This is called a polarized plug. The wider plug assures that you can only plug this cord in one way. You can only plug it in one way and not the other. How does that work? Well, let's take a look at this. This is a typical power strip. Electrically, it's plugged in, although it's not energized. I haven't turned it on yet. And you can see here, as I'm sure you've noticed many times, that we have a wide slot here and a narrow slot here. We have this other thing called a ground slot, and we're not going to talk about that quite yet, but you kind of have heard that. So you have a narrow and a wide. Now, by comparison, look at the plug that comes off of the radio. Both of the prongs are exactly the same size. And that was the way it worked back in the day. Plugs were not different sizes. They were the same size. They were both this narrow slot height, okay? So it didn't matter. You could plug it in this way or you could plug it in this way. It didn't matter. As a matter of fact, this plug is still non-polarized, right? It doesn't have a different sizes in the prongs, and we can still plug it in this way or this way. Okay, so now the question is, why is that? What's the big deal? Well, it turns out that electricity coming out of your wall isn't quite what you think it is. You think, probably is my guess, you think, well, hold it, there's electricity that comes out over here, there's electricity that comes out over here, and kind of if there's
some people would say, like if there's extra, like if there's a huge surge or something, then it overflows into this ground plug. And that actually is how a lot of people think of electricity. It's not wrong, but it's definitely not right. The reality is that there is electricity on one of these and not the other. The efficiency is that the power company is only going to send you electricity on one side, and the other side is going to be the return. So it's as if you think maybe, well, it's pulling on this side, it's pushing on this side, and then it pulls on that side, and then it pulls on this side. It's actually just pull, push on one side, and the other side just is there to connect the circuit. So what happens here is that we have one side that is what's called hot or energized. It's got a bunch of electricity here just ready to be used. And the moment that we connect it into something, then it returns back over here and just completes the path, okay? All right, and so we have a hot side, and then what we have here is called a neutral side, okay? And so the hot side is actually very energetic. There really is electricity there. Watch this. I'm going to turn on the plug here. And now what I'm going to do is I'm going to take this device. And this device is interesting in that it just tests, it basically determines if there's electricity just because electricity kind of gives out little radio waves. This is like a little electricity radio receiver. And so what we're going to do is we're going to put it down in here in the neutral side. I'm going to push the little button. Nothing happens. Well, okay. So nothing happens, big deal. I put it over here, I push it. There is so much electricity that's just sitting here, that it actually will register and make this thing go off. Electricity is here. Electricity not here. By the way, there is electricity here. That's something that people don't understand, is that it turns out that there is actually electricity energized here and here. This doesn't have electricity in it, but this one definitely does. And this one, in my view, really shouldn't, but it does anyway in most homes that are wired up. So here's the problem. You're saying, well, that's really interesting. I never knew that before, but so who cares? Well, when you're plugging in the radio here, right, and you plug it in here like this, this plug, once it gets plugged in here, is going to be connected, all right? And that electricity now is going to go all the way through the wire and be, as I reach over to get it, connected now to the metal. And we don't know which one it is. It could be that the metal of the chassis is connected to this prong or this prong. And if we plug it in this way, there's no problem if the chassis is connected to this prong. But if we plug it in over here, then there will be a problem because the electricity will go all the way up. It's energized, remember? Energized. And so if it goes up this prong, and this happens to be the side that's connected to the chassis, that metal, is going to have this electricity on it. And that will hurt. So just imagine, my mom is sitting there listening to the radio, and she is, changing the channel. She has a soup spoon on top here, okay? And then the soup spoon falls down, touches the metal chassis while she's doing the dishes. And she reaches down behind it because she's not aware of this, touches the chassis because the spoon is touching that. A circuit is made all the way to ground, and she gets zapped. And my sister and I become orphans. Not a good thing. Now, we don't want that to happen. So we're going to take some steps to make sure that our radio here is not going to be set up like that. We can make small modifications here to make sure that, first of all, we're going to change the plug. to this kind of a plug, all right? And then we're going to put a couple of other features into the radio that will prevent it from creating a circuit that could potentially shock us. Now, before I mentioned that it seemed like this particular radio was already designed with some protection in place, because here we see the power cord coming in, and it goes over here to this tie post, and then over here directly to the on-off switch. All right? There doesn't seem to be any direct connection between the line voltage, that's what we call this, that comes out of the wall socket, and the actual metal chassis. I have looked, and there are very, very few connections. There's one connection over here, sorry, my thumb's in the way, to this capacitor, and this may actually be a safety capacitor. I'm not sure about that yet. I'm going to have to check that. But other than that, it looks like they have attempted to isolate the line voltage from the chassis. But for many other radios, that is not the case. You can actually see where they've taken one leg of the power cord and actually connected it to the metal. So this radio seems to be safer, more safely made than most, but we're still not going to take any chances. At the very minimum, we're going to replace the plug so that we can get the polarization right, and so we will not have that potential chance. And then we're going to do a couple of other things as well to make sure that this becomes a much safer radio. Notice, of course, again, as I've said before, we're not going to plug it in until we replace these capacitors. Again, looking at the capacitors, if you're joining us late, notice that these are all wax paper capacitors. They are all bad. They are all bad. They have all stopped working as fully functioning capacitors. Are beginning to break down, and so we don't want to use these. We're going to replace these with modern capacitors. All right, so our next step is to now disassemble this radio chassis components. We're going to take off the speaker, take off the dial. We will disattach the antenna. The tricky part for the antenna is that it is actually soldered in both here. One end of the loop, this is called a loop antenna, is here, and then the other, you can follow that down, and that comes down over here. And I will have to unsolder those, remembering where they go, so that when it comes time to reconnect everything up, we connect everything up where it belongs, okay? So, let's get started. Okay, so we are going to disconnect the major components from the chassis here. And like I said, the first two bits are pretty easy, the speaker and the dial marker here. But the more difficult part is the antenna, because it is actually soldered in. This is where this can go wrong. We don't want to mistake what's going on here. We want to make sure that we get the antenna, when we have it unsoldered, that we solder it back in the right place. And so for that, I'm going to just be, I'm going to use my technology when I can. Just going to take a picture of this wire here. There's one. And here's the other. Just that easy. I'll make sure I actually get it in the frame when I want to take a picture of. There it is. Okay, so here's what I've done. And I did this because I'm both an idiot and not an idiot. So I'm an idiot because it's entirely possible for me to actually forget where the antenna gets connected. So I went and I printed off the pictures that I just took, and then I used the tools to just kind of highlight, look, here's where it gets connected over here, and here's where it's supposed to connect over here. I'm going to save that so that when it comes time to reconnect everything up, I will have that done. All right, so that'll be the tough part. Right now we're going to just start disassembling this mechanically, and that's very easy. All we're talking about is just a few screws, and then we'll just get right to that. Okay, so here we are. We're just going to take off the dial first, just a screwdriver here. And you'll notice that there are actually, this is both a slotted screwdriver and a little nut here. So I don't know, I'm looking at this and saying, my screwdriver's a little bit thick here. I think I probably, can I make that work? Yeah, there we go. All right, so comes out very easily. All right, you can see here, that's just all that it is. It's just a simple galvanized screw. Same thing here. There we go. Again, very easy. Actually, once I loosen it with the screwdriver, it comes out easily with my fingers. Except, you know, you have to turn it a lot. So there it is. Wow, it just comes right apart. And then you'll notice that there are these spacers here that are going to go between. So we want to save all of that. Here's the plastic shield and the plastic with the print on it. And then there's this this green backing, and you'll notice that there's some discoloration here, probably because somebody had attempted to maybe put some lubrication in here. I'm not quite sure why that would be the case, but we have a little bit of bleeding here. I don't know, maybe there's some cleaning we can do here, but you know, it's not in bad shape considering that it's a very old piece of equipment. So we're going to save that. We'll take a look at the plastic shield here. There's a little bit of surface dirt, but basically look at that. That's not bad. The silk screen painting looks pretty good. We will clean this up with some very mild detergent, mostly water. Anytime we try to use any kind of cleaner at all, the paint that's in here is going to just come right off. We don't want that. Any kind of solvent may attack the actual plastic itself. We don't want that. So we'll save those bits and pieces. And again, these small bits and pieces, remember what we do. We're going to find our little small pieces container and put them in that. Okay, so again, found the small pieces container. We're just going to put all that in here, which is fine. Now the next bit is, again, very easy. Just this little pilot light holder here, and we just unscrew it, and there's a little nut in the back. Once we get it started, it's very easy. Comes right off. There we go. And you'll notice here that this is actually just a bracket. So we're going to slide that off, and then the pilot light receptacle here is just free. We will put the nut back in with the screw, and again, that will go in our small parts container. Making sure we just don't put it somewhere where it's going to scratch anything else up. And now we're going to deal with the speaker. Speaker, again, is very much like the dial, same sort of screw and spacer arrangement. So we go here, we're just going to loosen these. And then they come out very easily just with some hand strength here. Now, here's the thing. The speaker leads are going to have to get unsoldered. Now that's fine. That's not nearly as difficult because speaker leads are it's very obvious what they are. Here's the speaker, and there are the leads, and we just unsolder those and we'll be good. Speaker leads, it doesn't matter which lead goes to which part of the speaker in this case. So we're going to just unsolder those, and that'll take care of the speaker. So first of all, I apologize for the background noise. We got that taken care of. All right, so here we are. We're just going to take a soldering iron here. This is my soldering iron. And we're going to just unsolder these. It's very easy to do. I'm going to grab the wire here, apply the soldering iron, wait for it to heat up. And just going to wiggle it a bit, and there it goes. And we should be able to pull that wire out very easily. Well, that's what I say. There we go. Come on. There we are. So there we go. Same thing over here. And now the speaker is free of the radio. Now you'll notice here, as I had mentioned, I think earlier, this is a new speaker that I had put into the radio just a little while back, and just because the other one had deteriorated. But now, so again, this speaker was matched to the other one. You'll notice that just every component has particular values. In this case, this is a 2.3 ohm speaker. Let me get that there, and it is meant for 2.5 watts. Again, this is exactly the same as the speaker that I pulled out of it. The speaker from what we think is 1954. All right, we're going to have to detach the antenna leads. And so here it's simple matter, just grabbing the antenna wire, trying to melt off the solder. Solder's been here for decades. So it just turns out though that solder just is pretty much the same. I'm just going to manipulate it while it's still hot. And there it goes. That is done. So now we still retain the connection here to this green lead to the variable capacitor, but now the antenna is electrically free. All right, so the second thing we need to do is take the antenna wire off of its connection here to the terminal. Now this is a little tricky because this terminal connects actually several components. It connects the antenna wire, which is here. It's probably hard to see in the camera, I'm sorry, here. It also connects this capacitor, this resistor, and this wire lead here that goes over to a tuning capacitor over here. So there are several things that are wired into the same spot. So that's going to make it a little bit trickier to get the antenna free from this spot. So I'm not going to do that while it's on camera because it's very awkward to try and do that and allow you to be able to see it. So I'm going to do that, turn off the camera, do that, and then show you the result. Okay, antenna wire is free. That's the antenna wire there, this very, very thin wire right here. And so now that's free, and we're going to feed that through the hole and detach it mechanically from the rest of the chassis. Oh, sorry about that. So that'll be easy enough. Again, same sort of idea here. We pull out. Same sort of idea here, just unscrewing the cardboard antenna assembly from the metal chassis here and here. Who knows the last time these screws were messed with? It's entirely possible. These screws have been in here for, what did we figure? 70 years? 60 years? All right. So, once we have those free, and we can see this part is free, and then down here, we have the wire here that's free. We're going to just pull that gently through, and now that's free. The antenna assembly is now free. Now, the antenna loop here is very typical, and the only thing that we're really worried about is whether there are any breaks in the wires. It looks like the antenna is actually in pretty good shape. So it looks good. We're going to be okay with this and just leave it like this for now. Maybe clean off some of the surface dirt. Again, very, very mild, but the antenna assembly is now free. Of course, small little bits go in our small little bits container. And so that we don't lose them. All right, so now we have the chassis. It looks pretty good. It's a little bit easier to handle, a lot easier to manipulate. Just hold, you can hold things better. There's some things that we're going to have to do. We're probably going to want to lubricate these knobs with some cleaner. I will clean off some of the surface dirt here that's kind of cruddy, and then we will start working on replacing these capacitors. Okay, now that we have the big components off and it's a little bit easier to manipulate the chassis, I want to point out some things that are going to be trouble areas that I'm going to be looking at specifically as we begin to rehabilitate the guts here. There's a couple of things here. I want you to notice that this particular capacitor is discolored over here, and it's actually kind of coming apart. The paper is coming apart. Now, I already know that this is not a good capacitor because it's just plain old. It's just too old to work. So this is definitely no good. But I want to point out something here. You see this resistor here? See how it's kind of very, very mottled, and I'm not sure what's going on. Something's damaged with it. Let me get that in closer. See if we can see that. See that? It just doesn't look right. So that we're going to have to test. Probably replace, because we don't, it's so deteriorated on the outside. I don't know if it's because of the chemicals that were released from here or because it overheated. I actually don't know. I'm going to have to figure out what the value of that resistor is and then replace it. Over here, I want you to look at this capacitor here. Notice how it's misshapen. I'm trying to show you there an angle. There's resistor wire lead is kind of in the way here. Notice that? That is not right. So that's going to be a capacitor that we're going to have to replace because that just can't be right. That's not good. All right, then let's see. Anything else here? Everything else just looks kind of in a similar sort of what you'd expect to see here. I did notice that there's a little bit of a problem with this tube socket. I'm not sure if I want to take that on. That may be a little bit more advanced for me, and I'm not sure I even have the replacement socket that would work. So that's a maybe, but I can tell that there's this particular solder joint isn't right. So someone else has been in here perhaps to work on it and did the best they could. We may have to leave that sleeping dog lie. But again, other than that, I just didn't see anything else that was any danger signal to me. The other part that I did notice was on the dial face itself. So here's the dial face, and you'll notice a couple of things. First of all, it's clear plastic, which is fine, and the green cardboard goes behind. You notice here that there is a number. Now, my guess is that this dial is going to be a different part for different parts of the country where there are going to be different stations of that time that would be in different parts of the country. So WGN in Chicago is not going to be on a West Coast dial. If you'll notice, each one of these stations begin with a K. K was the first letter of any station that was west of the Mississippi. Second thing is you'll notice this little divot up here at the top. Now that's because of the dial light. The dial light would get hot and it began to melt here because it was resting right on the plastic. Again, nothing serious, but it's just something to note. I did clean this up with some water and nothing more interesting than hand soap. And so just got a little bit of that surface dirt off. There is some scuff marks here, which are fine. But basically, mom's cigarette stains, my peanut butter fingerprints, all that stuff has been taken off. And so that's a fairly clean piece right there. All right, so we've taken apart the radio in its kind of large bits. And what we'll be doing next is we'll be cleaning off the chassis, as I had mentioned. I'll be storing these parts where they will not get lost or broken. And there'll be a bit of a delay because now it will be time for me to start looking and ordering the parts that I'm going to use to replace these components. So this will involve some testing on my part and then actually ordering up those parts and then waiting for those to show up. And so that's going to take a little bit of time. Our next episode, we may go through a little bit of testing and how we're going to look at that. So I appreciate the fact that you hung in with me and give me a little like, and that would be super. See you next time.